Just as an FYI to you, though, you will have a quiz next week. Okay, quiz next week. Probably Wednesday, but maybe Thursday. I didn't write it down yet because I'm not sure which day. Next week, Wednesday or Thursday. Sure, not Friday. Yes, quiz. Quiz next week, either Wednesday or Thursday. Next week. Yes, you do. You don't have school next week, Friday. It's not on Friday. It's Wednesday or Thursday.
Wait, why don't we have school on Friday?
Parent-teacher conferences are Thursday after school. And then Friday was supposed to be a conference morning, but we don't have conferences. All right, so again, today we're going over simplifying complex fractions. So a complex fraction is a rational expression with a numerator and or denominator that is also a rational expression. So the following expressions are complex fractions. So here I have a fraction in my numerator over that denominator. Again, fraction in the numerator over the denominator. Here I have a fraction in the numerator and the denominator. And in this one, I have a fraction as part of the numerator and part of the denominator. So if you have multiple fractions within a fraction, it is a complex fraction, and we can simplify those. So to simplify a complex fraction, first rewrite it as a division expression. So in number 1, we have our fraction here in the numerator over another fraction. Now this fraction bar just means divide. Okay, so that means divide by. So I can rewrite this as x minus 2 squared over 2 times x squared minus 5x plus 4 divided by, instead of that other fraction bar there, so divided by my other fraction, which is x squared minus 4 over 4x minus 10. Okay, now this is exactly what we did yesterday. Okay, you have that division of your fractions. So if you have a division symbol here, what do I do to that second fraction? You flip it. So you need to take the reciprocal so I can multiply. So this would be x minus 2 squared over 2 times x squared minus 5x plus 4 multiplied by that reciprocal. So 4x minus 10 over x squared minus 4. Now from here, this is where I want to factor so that I can simplify. So in my first fraction, this is already simplified, right? I'm just going to rewrite that as x minus 2 times x minus 2 because that's what that square means. Okay, it means you're multiplying it by itself. Okay, then in the denominator, we still have a 2. I need to factor this, so I'm going to use the x method. Okay, so factor this one using the x method. So what adds to negative 5 and multiplies to positive 4? Negative 1 and negative 4. Okay, so I would have x minus 1 times x minus 4. Okay, so I was just factoring right here to right here. Okay, same thing in my second fraction. I want to factor this. Okay, so since it only has 2 terms, we want to factor what they both have in common. What do both of those terms have in common? A 2. So I'm going to factor out a 2. And I'm left with 2x minus 5. Okay, then in the denominator, I have an x squared minus 4. How do I factor that? How do I factor that one? So difference of squares. How do you factor a difference of squares? What? Yeah. No. You split it into x minus 2 and x plus 2. So when you have a difference of squares, because these are perfect squares, you split it into that plus and minus quantity. Okay, so from here, this is where I get to cancel from the numerator and denominator. So what they have in common. So here I have an x minus 2 over an x minus 2. I have a 2 over a 2. Where? Where? I can't cancel that. It's not the same. Are those the same? No. You can't cancel those. This one is x minus 2. This one is x plus 2. Cannot cancel those. Okay, I don't have anything else in common, so then I would just rewrite this as x minus 2 times 2x minus 5 over x minus 1 times x minus 4 times x plus 2. That would be your final answer. Okay, don't try and FOIL anything out, just leave it as it is. All right, questions on number 1. It's very similar to what we did yesterday. You're just rewriting it first from what you were given. All right, then looking at number 2. Okay, number 2, same thing. This middle fraction bar here means divide. Okay, so you need to divide those two fractions. So I can write it as x squared minus y squared over y squared minus 49 divided by, instead of our fraction bar in the middle, y minus x over y plus 7. And since this is a division expression, we want to change it to multiplication, so we multiply by the reciprocal. So you need to switch your numerator and denominator. So multiply by that reciprocal. And then from here, this is where I can factor so that I can simplify. So yes, Kason keeps telling me how to factor this one. So you do factor this into x plus y and x minus y. Those are a difference of squares. Okay, it is a difference of squares, so I factor it into plus and minus. Okay, that's over. Again, this one is a difference of squares. Okay, 49 is a perfect square, right? So I would factor this into y plus 7 and y minus 7. Okay, then I have my second fraction of y plus 7 over y minus x. So from here, this is where I can start to cancel. Now I do have a y plus 7 over a y plus 7. Now these two, this x minus y and y minus x, are not the same, but they look very similar, right? Do you remember what I do to make them the same? You factor out negative 1. Factor out negative 1. Okay? So then I would have a negative 1, right? Because I factored it out. I still have x plus y because I didn't factor it out of that first quantity, but I'm factoring it out of this quantity. So that means I need to change the signs for both of those terms. Okay, so negative x plus y instead. Okay, then that's over what I have remaining here. That is y minus 7 and y minus x. Now if I look at these two, now both of my x's are negative and both of my y's are positive. So now those can cancel each other out. Okay, so then I end up with that negative, you can keep the 1 there if you want. You don't need the 1. Okay? Negative quantity of x plus y over y minus 7. Okay? Questions on how I set up number 2? How I simplified number 2? Do you have questions on how I simplified? Did we get it all copied down? You're with me? All right, last example. So again, middle fraction bar here means divide. Okay, so we need to change our fractions here. So we have x squared over 9x squared minus 4y squared divided by x cubed over 2y minus 3x. Okay, so that's my first step. Change it into a division expression. Since it is division of your fractions, we need to change it to multiplication. So we multiply by the reciprocal. So 2y minus 3x over x cubed. And from here, we factor like we did yesterday. Now, in the numerator of my first fraction, I can't factor anything, right? Can't factor anything. So I leave that as x squared. In your denominator, can I factor that? Yeah, how do I factor that?
3 and 2. 3, no, it's x plus, no, 3x plus 2y. And then 3x minus 2y.
Yes. This is also a difference of squares. Okay, so this is a perfect square, and this is a perfect square. So I can split it into that plus and minus quantity for that difference of squares. Okay, then I'm multiplying. I can't factor this 2y minus 3x, so I'm just going to leave it as it is. And I can't factor the x cubed. So again, leave it as it is. Now if I have x squared over x cubed, I can cancel those, right? But then where is my x remaining? In the denominator. So I still have 1x in the denominator. Of which? This one? Yeah, whichever one you want. It doesn't matter. Yeah. I usually do the numerator just because it's easier. So these ones look similar, right? Just like we had before. So they're not quite the same. So again, we need to factor out -1. Okay, so we want to factor out that -1 so that we can cancel out that quantity. So when I factor out -1, I change the signs on the inside. So now I have -2y plus 3x, okay, over 3x plus 2y times 3x minus 2y. Now which ones cancel? The top one, and then which one of these two?
Oh, the bottom one, the bottom right.
Bottom right. Okay, so I have a -2y, positive 3x, positive 3x. So then I'm left with -1 over, do not forget the -1. Okay, if you cancel everything in your numerator, you still have a 1 there. Okay, if you cancel everything in your numerator, you still have that 1, in this case a -1. And then I have 3x plus 2y in the denominator. And that would be your final answer. Okay, any questions? Okay, it's very similar.